Okay, good morning. Today we are going to discuss about the AC machines. The first unit you all know, that is the unit 1, the alternator. Okay, the alternator, in the sense it can capable to generate the power. Okay, it can the mechanical input, that is the mechanical energy, can be converted into the electrical energy. From the mechanical energy you all know, it can obtained from various sources, right? From the turbine or diesel engine or any other sources like rotational, any rotational force, it should be which is connected to the shaft of the alternator. It can be easily converted from the mechanical energy into the electrical energy, right? That is so it is also called as a synchronous generator. Okay, so it can capable to generate the power. That is the basic principle of operation. So the continuation of that is the construction we are going to discuss. The construction, this is the actual construction of the three-phase induction motor, three-phase alternator. So here you see that is the outer surface, that is the yoke. Okay, three-phase alternator, that is the outer surface, that is the yoke. The yoke, it can provide the entire mechanical support of the machine. Okay, then the internal construction, that is the stator part. This is all the stator part. That is the stationary portion. It's have the stator slots and the winding. Okay, this is all the stator slots. This is the stator winding, three-phase stator winding. Okay, so whatever the input we are giving in the mechanical input we are giving into the rotor, so the rotor initially it can be start rotating based on your mechanical input. So during the rotational force, so while it is rotating, here the induced EMF is generated. The generated EMF reach over the stator also. So all the based on the rotational force, here the output supply will be produced. That is the RYB. Okay, so in the based on this rotor construction, again further it can be classified in two categories. One is the that is the salient pole. It can be projected like this. So that is the pole head. Then the internal field winding of the rotor, that is the copper winding. So the north and south pole. So here it is the slip ring. This is the carbon brush, right? So the carbon brush, slip ring, and the pole head, and the windings, copper windings. So this is the construction of the total construction of the three-phase alternator. Okay, so that is the salient pole. If it is the non-salient pole or cylindrical pole, it is like that. Based on the rotor construction, it is divided. So here that is the cylindrical pole. Then the cylindrical pole, in the sense, here you see that north and south pole, here also the same, but here in the salient pole, the pole has been projected from the rotor, but in the cylindrical pole it is not projected, but here it is have the slots. In the slot it is also having the winding. Similar to that, here also we are giving the mechanical input to the rotor. So the in the rotor it may rotate it, and finally we can get the output of the RYB, that is the three-phase output supply. So you all know that is the basic formula, that is the NS, it should be equal to 120 F by P. Okay, here that is the synchronous speed, then frequency and number of poles. Okay, so here we have whatever input you are giving in the shaft, in the rotor, it may have the shaft like this. If you are consider the shaft, so the shaft, it may you can connect the pulleys and drive system. So while you are giving any mechanical input in the pulleys, so it may be connected with the any turbine or diesel engine or wind turbine or water turbine or gas turbine, whatever it is. So the shaft, it should be directly connected with the help of drive pulley system. Okay, the drive pulley system in the nothing but here the shaft itself, it's connected on pulley. So you can connect the through the belt, that is the transmission equipment, that is the belt. So while the turbine is getting rotated, so the same speed shaft also getting rotated. That way we are giving the input to the rotor, both the rotor. Okay, either cylindrical pole or non-cylindrical pole. So that's all about the overall construction of the synchronous generator or a three-phase alternator. So you should remember these all things. So the mechanical input can be converted into the electrical output, and here the stator slots which we are used, that is the semi-closed slots. There are three different types of slots: semi-closed, fully closed, and fully opened. Okay, so among these three we are using here the semi closed stator slots. Okay, then these all parts you should remember: yoke and stator slots, stator winding or stator core, and the rotor. In the rotor part is a slip ring and brush, and the pole head and rotor winding, that is a copper winding or field winding. This is the armature winding of the stator. Then so this all the parts you should remember, and while you are explaining this construction, you should explain one by one, like rotor and stator and yoke, and each and every parts you should explain, and you should mention the drive pulley system also, because the drive pulley, without the transmission equipment or drive pulley system, we can't able to give any mechanical input, right? The drive pulley system, it should be connected with the sources of the mechanical input, like wind turbine, gas turbine, or diesel engine, right? So whatever it is, it should be connected with the mechanical input. So here through the shaft, this shaft, it should be connected to the rotor. So the rotor, it is initially getting rotated. So while the rotor it is getting rotated, the generated EMF can be reach over to the stator. So then from the stator we can get the output three-phase supply. It's all about the basic principle as well as the working of the three-phase alternator. So the continuation of that pitch factor, distribution factor, and EMF equation and armature reaction, that all we are going to discuss further. Okay. If you have any doubt about in the construction point of view, you may ask. Okay. Okay. Thank you.